Okay, welcome back to the classroom. This is Mr. Wong speaking here. We're going to go through a physics problem for Module 5, which is Advanced Mechanics. Question 16 here. We have long period comets believed to come from a cloud that lies far beyond the outermost planet of our solar system. When the comet is inside our solar system, our particular comet travels in an elliptical orbit around the sun. However, majority of its orbit time occurs beyond the outermost planets of our solar system. Explain how the motion of the comet in its orbit supports Kepler's second law. Include a diagram in your answer. So why don't we firstly show what this actual, discussion point is. We have the sun in the center. Okay. We have the outer regions of our solar system. So this is where, the outermost planet, let's say Neptune, whatnot, is in. So this is the region of our outermost planet. Okay, just change color. It's saying this comet comes in an elliptical orbit. So an elliptical shape would look a bit more like this. So this rounder shape, like so. Not completely elliptical, but it shows what it is. Okay, so why would the comet, let's say out in this position here, be traveling a longer period of time out here than it is in here? Well, the idea is very simple. As it gets closer towards the sun, there is a stronger gravitational pull, and so it accelerates the motion of our comet around here. Okay, because there's an acceleration, it's moving a lot faster as compared to when it's over here. But obviously that's using Galileo's explanation. That's not necessarily Kepler's second law. Kepler's second law states that the planet within the same time interval will cover the same amount of area. So A1, and then let's say it moves from here to here. I'll just redo that. So it goes from here to maybe, let's say here, arbitrarily speaking. And it covers a much smaller distance. But the area, A1, is still equal to A2. Okay, so what's the explanation according to his second law? Well, according to Kepler's second law, within the same time period, the planet in its own orbit will cover the same amount of area. So if it's covering the same amount of area, but clearly in this case, the position where it's closer towards the sun, it's traveling a greater distance compared to our position in A2 here, would imply that the speed in which it's moving at A1 is also much faster. So what we can also say is the time here is the same, but the distance traveled is greater here than it is here. Also, that means for the velocity, it's also the same idea. Okay, so continuing on with that explanation, let's actually try and put that in words. Okay, so like we said, within the same time period, within the same period of time, the comet will cover the same amount of area. This implies that the comet will travel much larger distance when it's closer towards the sun, and also travels a lot faster. The comet will travel a greater distance nearer to the sun and also much faster. Okay. So if that was the case, if it's traveling a lot faster in the same period of time, it means and also travels a greater distance, it's going to not be in that same position for a very long period of time. Okay. So this is consistent with Kepler's second law, as the comet will spend more time orbiting outside the most outermost planets as it's moving slower and covers a shorter distance in the same period of time as compared to one that's closer to the sun. Cover a shorter distance compared to if the comet is orbiting near the sun. So that's essentially what Kepler's second law is trying to tell us. It's essentially saying a comet orbiting around the sun. Well, firstly, the first law states that it's elliptical. The reason why it's elliptical is because although they cover the same area in that same period of time, the distance traveled are a lot shorter. Might actually extend that, make that a bigger distance. Okay, so here, a bigger distance covered, a higher velocity, whilst over on this side, a smaller distance, lower velocity, hence it covers, it needs to cover a greater amount of distances in order to leave this particular part of its orbit and come towards here. If you found this explanation of Kepler's second law useful, hit that like button, and I guess I'll see you next time for other explanations with